Okay, modeling and flat rate depreciation with recurrence relation. So the depreciation is divided into three, and those are the three ones we're going to look at. I'm going to look one at a time. We have the flat rate depreciation. The same amount is depreciating throughout flat rate. And you have got the unit cost depreciation. And you have got reducing balance. Reducing balance. With the flat rate and the unit cost are both linear. And they're both linear. The same amount is depreciating throughout the lifetime of an item. Reducing balance is geometric. It's similar as the compound interest formula, except that it's minus. And these two, this formula is for the flat rate depreciation, and when we look at the unit cost depreciation, we still use the same formula for unit cost and flat rate. Whereby reducing balance, we use different formulas, so we use this. And we'll discuss further when we get there, the reducing balance. So let's have a look at the flat rate depreciation, how it's done. So this is D is the amount that's depreciating, how much is depreciating in a certain given period of time, normally in a year. The amount So D is the amount that is depreciating in a given time. And the percentage flat rate depreciation, amount of depreciation over the initial value times 100%, that's how we calculate. Alright, let's have a look at an example. Fast Word Printing Company bought a printing press for $15,000 and chose to depreciate it by flat rate method. And the depreciation was 15% of the cost price each year, and its useful life is 5 years. So in other words, after 5 years, it's useless, in other words, yes. So that is basically the scrap value. The scrap value is the value after the depreciation and the useful life of an item. Okay, how much will it cost after that period of time? Calculate the annual depreciation and, well, how much it is depreciating each year. So that is the D value. So D equals to R over 100 times V naught. V naught is the amount that it costed at the beginning. The initial cost, in other words. That's the initial cost, V naught. And want to find out how much it is after, well, how much it's depreciating. So that's going to be 15. That's the rate of depreciation times 15,000. So that gives us a value of 250. So that's how much it's depreciating for A. That is how we calculate A. That's how much it's depreciating, let's say. So set up a recurrence relation to represent the depreciation. So that's going to be the V sub n plus 1. In order to get the next term, we have to reduce the previous term by the D value. So now that's how we do it. So now this can also, so we know that we got our D values to be 2,250. We can just substitute that value back into this expression. All right, that answers the question. So how much it's depreciating. So now if I want to find out, write the depreciation value. So if I want to find out, what is that? Write the value, depreciation schedule for the useful life of the press. Use it to draw a graph of future value against time. So this is best done if you use your calculator. So what you do is, because remember that the lifetime, the useful life is 5 years. Our initial value is 15,000. So now we need to find out. And remember that we actually calculated our depreciation value as to be 2,250. So let's go and use our CAS. So back to the calculator. Press Control Doc. Go to the spreadsheet. And just put here the time. So remember the time is 5 years. So that's going to 1, 2, 3, 4, 5 years. Initial cost was basically 15,000. So we're just going to call this one as to be the future value. What will be the future value? Well, at the start was 15,000. So now we basically subtracted every time by 2,250. So all you need to do is this cell. So we're just going to put the equal sign and this cell minus 2,250. You press enter, and that's how much it's going to cost after 1 year. And you can just do the fill, put the cursor in there, press menu 3, see how we go, and that's it. The calculator will do the rest for you. Just gonna do the fill, just put the cursor there, press menu 3 and 3 again. And that's it. All right. Now we're just going to label here what will be the future value. So that's going to be the future value. Yeah. So we're just going to remove the space in between. So, yep, that's it now. And they asked us to graph this. We graph this. So now this is the future. Well, we're just going to press Control, Doc, and number 5. So this is going to be our future value, time, sorry, that has to be time. And this is the future value. And that's how it would look like. And the question was asking us to find the scrap value. Scrap value is the value after a certain period of time. So now, because you identify the scrap value, so in other words, we were told its useful life was 5 years, so that will be what is the value of the printer after 5 years. So go back to your graph, you put the cursor in there, so that's going to be 3,750, so that will be your answer. The scrap value will be 3,750. All right, and let's put that number. So C, so the C we have done using the CAS, we've done that, and D will be 3,750, and that's how you do it. All right, and let's have a look at another example based on the same concept on flat rate. It's this is an exam question, and now, so we need to find out which is the correct one. So obviously it's not going to be any of these because this is geometric, so this is not this are not the one. It's either this or that, and it cannot be plus, it has to be minus. So the D value has to be R over 100 V naught. Our V naught is 4,050, so we're just going to substitute, and that's 10%, 10 over 100 times 4,500. So that's going to give us 450. Off you go. And that is depreciation, so that has to be minus. So this is the correct option. All right, that's how you do it. Our next lesson will be based on reducing balance and unit cost depreciation.